Now we have, we're going to be talking about geometric series. I'm going to get fancy with some cursive here. Okay, so geometric series, these are going to come in the form of, so we have our series, and this is going to be like r to the n. So when this happens, then it's the sum of this series is going to be 1 over 1 minus r. When, this is a big when the absolute value of r is less than 1. Okay, so just in general, I was just going to make a comment that when in doubt, the critical value of anything, like something being less than a number or whatever, it's usually going to be 1. 1 is the deciding value for a lot of things. So, I mean, if you had to guess some value, just guess 1. Yeah. Okay, so this is kind of similar to what we've seen before, of like 1 minus something, and then the series would look like this, and then we have x to the n, remember this one, and then this was for absolute value of x being less than 1, and then this turned out to be something looking like 1 plus x squared plus x to the third, and etc. Yeah, so we've seen this before, the same form. And also here, I'd like to point out that this r can be anything, basically. It doesn't have to be like one single x or anything like that. It could be like x over 4 or something, and then you'll have an x over 4 here, raised to the n power, and an x over 4 here. Okay, so it can come in any form, and then there would be an x over 4 here. So then if that were the case, then absolute value of x, so I'll just write it here. Let's say your r is x over 4, being less than 1, then our radius of convergence would be 4, right? To solve for x, you get 4. Anyways, okay, so now more applications of the power series. So here's our normal power series, right? You're gonna see this a lot, so we're gonna get really familiar with this form here. Okay, and then our interval of convergence, as we said before, is this, right? And then what we can do now, because we like to do this in calculus, is differentiate and integrate, right? So what we can do, like let's say we take the derivative of it, then we'll just manipulate this form. We'll just differentiate, right? So we're gonna, this a sub n, we can consider as a constant, so that just stays there. The n, the power comes down in front, and then we have everything in the middle stays the same, everything inside, and then the power goes down by 1, so that's n minus 1, okay? So that'll be the form for the first derivative, and on the other hand, let's say we were to integrate. So let's integrate our power series, and then we'll go backwards, basically. So here, now we're going to add 1 power, well, the constant just stays in the front, and then we're going to add a 1 to the power, so n plus 1, and then as you have to do an integration, then you have to compensate for this new power, so you have to divide by that same thing. Okay, so then we have this as our integrated form. Okay, and then sometimes you'll have like plus a or plus whatever. This is like your plus c, and they say a just because they don't want you to get confused by the c here, which means center. But this is like your random constant when you integrate indefinitely. And an important part about this, both of these, when you take the derivative and the integral, they will have the same interval, and radius of convergence as the original power series. Okay? Alright, moving on to the next thing. We're going to do an example of, let's see, we can differentiate on this one. This is what we're going to be doing. So, example, we're going to prove, I believe this is in your book. If not, then, well, I don't know, I'm not sure. Prove that for -1 to 1, 1 over 1 minus x squared equals 1 plus 2x plus 3x squared plus 4x to the third plus etc. Okay, so from here, from the given interval, we know that the radius of convergence is 1, right? And our center is 0, as we can tell. What's exactly in the middle of the, well, the center is basically what's in the middle of your interval here. So, yeah. Okay, so what we can do here is think back to the simple case. This is pretty much the simplest power series you're going to ever encounter, is the x to the n, which is 1 over 1 minus x, which looks like 1 plus x squared plus x to the third, and it just keeps going up by the power, right? So that's what that one looks like. And then if you think about it, let's so this is like our f of x power series, right? So let's take f prime of x and see what happens. So if we take the first derivative of this, we have to take the first derivative of the other side too. So let's do this one first. So that's going to be a negative 1, because this is to the negative 1 power, right? Well, I'll rewrite it real quick. This is 1 minus x to the negative 1, okay? So the negative 1 comes down in front, and then everything in the middle, everything inside stays the same, and then you subtract 1 from the power. So that's going to be, wait, hold on. Sorry, chain rule. And then times another negative 1 from the inside, right? Okay. So this is going to be equal to, the negatives cancel here. So we get 1 over 1 minus x squared, which is what we want, right? So we found the left side. Now let's confirm the right side. So we differentiated this part, and now let's do the actual terms, okay? So the derivative of 1 is 0, so then we have 0, plus derivative of the next one, which is 1, plus derivative of this, which is 2x, plus derivative of this is 3x squared, plus, and we'll do one more, to the third, plus dot dot dot. So there we have it. We just confirmed their statement that they wanted us to prove. And this is also, as I said before, this will have the same radius of convergence, same radius and interval, interval, I will abbreviate, of convergence, okay? So that would be from negative 1 to 1, convergence. Okay. All right. Now we're going to work with differential equations. So this is the way that my calculus teacher used to refer to differential equations. And I mean, I guess it makes it seem fun for a calculus subject. So that means differential equation. Equations. Okay, so what we're going to do here is, let's say in these kinds of problems, you'll be given an initial condition, okay, condition, such as, I'll write a little example here, because I think these are best explained by examples. So they'll give you an initial condition like y prime equals y, and y of 0 equals 1, okay? So what we have here is something that is, let's say it's like y equals, our initial one is the power series, is the normal power series that looks like something like this. And we have our a sub n and then x to the n, okay? We'll make the center be 0, okay? So like x minus c is x minus 0, okay? And then what this looks like is a0 plus a1 x, x minus 0 to the n, which is 1, plus a2 x squared plus a3 x to the third, and etc., etc. All right, so then what would our y prime look like? So that we can examine this relationship, we would have f prime of x, and then this, we've done this before, we'll bring the n down in front, the power, n to the a sub n, x to the n minus 1. So then these ones, we can just differentiate the terms on the right. So then we get a1 plus 2a2 x plus 3a3 x squared plus, and then I'll write one more. Then we would have a 4, x to the third, and etc. Okay, so in this case, so we found the y and the y prime. So for y prime to equal y, so for this power series to equal its first derivative, then these terms, the constants would have to be the same, right? So the constants and the coefficients have to be the same for everything. So what we have here is actually like a set of mini equations, I guess you could consider them. So a0 would have to equal a1 from the constants here, plus, and then they would have, in front of the x's, these like terms, they would have to be a1 equals 2a2, okay? And then let's look at the x squared ones. Then we have a2 equals a 3 times a sub 3. And then we'll do one more. a3 would have to equal 4 times a sub 4, okay? So in this case, then we would have, I'm going to move it around a little bit. So let's say we have a1 here equals a0. That was from the first one here. And then I'll write the second one, a2. If we solve for that, that would be a1 over 2, right? a1 over 2. Let's solve for a3. a3 now equals a2 over 3. And we'll go one more. a4 equals a3 over 4. All right. So if you can see, there's kind of a pattern here. So a sub n, that would be a sub n minus 1. So the previous term, basically, that's what it's saying. So whatever term we're looking at is equal to the one right before it divided by n, right? And you can verify this by plugging in like 1 or 2 or whatever. So for example, a3 equals a3 minus 1, a2 over 3. And we can see that that's right. So what this is called, this has a special name called recursion relation. In that you can basically, like, provided the a0, you can basically get all of the following terms, right? Because if we have this a0, then you know what a1 is. And then from that, you can find a2 because you're using a1 in it. And then you can find a3, a4, and so on. Okay, so let's see. We have, so that's it for that topic. And then I'd just like to write two, to finish up this section, I'd like to write two, I guess, prevalent or like important series that you'd probably find it useful to remember. And you'll see them quite often, so you'll probably remember them anyways. But e to the x can be represented by this series, this infinite series of x to the n over n factorial. So this is going to look like 1 plus x squared over 2 factorial plus x to the third over 3 factorial. And there's pretty much a distinctive pattern here going on. So then you'll just keep going on and on. Okay, and the other one that I'd like to share, we've seen this before. I just like to stress it. So then this one is going to look like this, where we just have x to the n. And the important part here, well, this is just going to look like 1 plus x squared plus x to the third plus blah, blah, blah. Okay, and this is valid for, they use this terminology like, on what interval is it valid for? And it is valid for absolute value of x being less than 1, okay? And again, the x here, it doesn't have to be a singular x. It could be, just think of this as like a u spot, okay? So this is like u. You could have anything in this u spot. So then you would just replace all of these with u squared, with u's, basically. U to the third, etc. Okay, so u could be something like, I think I made the example, x over 4. So then you just stick x over 4s in each of these spots. Okay, so that does it for 11.6.